Ciao, everyone. That's the only Italian I managed to learn in the last 2 days. My name is Ishan Khanna, and I'll be presenting my talk called Roasting Google APIs on a Firebase to create Uberritos. It's quite a heavy title. Let me break it down for you. The most important parts, Google APIs, Firebase, and Uber. So a little bit about myself. I'm a graduate Android developer at Booking.com, and I am also a PMC member at Apache Fineract project, which is currently under incubation. And I'm an Android code maintainer at MIFO's initiative, which is an open source microfinance initiative. And they're helping eradicate poverty throughout the world, one line of code at a time. What's the agenda for today? We'll do a deep dive into Firebase, and we'll also glance over the APIs provided by Google, like Google Places, Google Maps, waypoints, distances. And then we'll try to create an app like Uber just to make it a bit more interesting, because I just don't want to talk about Firebase and then you people go back. So let's look at the overview of what Firebase as a platform actually is and what you can do with it. So like the image displays, you can develop with it, grow, earn, analyze, and it provides you with everything that you need to do and know as an Android developer. So backend services, what does it offer? It has a real-time database. It provides support for authentication. It provides support for hosting and storage of your files. It has support for cloud messaging. Remote configurations, quite an interesting thing. And then it also has app quality services. So once you've written some code you're about to ship, you may want to check that it's up to the mark so you don't get negative reviews or don't lose customers. There's a test lab for it. We'll look into that. And there's crash reporting. So for those of you who used to rely on Crashlytics, Fabric, and stuff like that, we've got you covered here. And I also got to know that Fabric has been acquired by Google. So yeah, they're all under the same tree now. With the growth, you can use dynamic links, app invites, to acquire users. Once you've acquired them, you may want to re-engage them. So you can use notifications for that, and you have app indexing. We'll look into that. And then in the end, everybody wants to make money. Ads are one of the best ways to do that on the apps. So you earn using the in-app ads. And everything that you see here, you can do through Firebase. You don't need anything else. And the most important thing in the center, you can also do analytics. So everything that you're doing, you know what is working for you and what is not working for you. So any app that you create, you need some authentication. You want to identify your users uniquely. Firebase provides a very nice solution, an easy-to-use solution to us. So you have support for emails and passwords, social providers like Google, Facebook, Twitter, GitHub, any other that you want to use with the OpenIDs thing. And then it has support for OAuth 2, and also anonymous login. Now, anonymous login is quite an interesting feature that I'd like to pause and talk about here. Let's say you have an app, it does XYZ function, but it doesn't really require me to provide you my full name and details and stuff like that. If you just want me to have a glance over what your product can actually do, anonymous login can really help you. So it actually creates unique IDs for your guests. You let them do what they want to do with the app, and once you think that they are deep down the funnel, and now they might want to convert, just pop a dialog asking, like, do you want to sign up? Do you want to log in with Facebook? This can really help increase conversion for you. And then if you have any other existing solution, it works with that out of the box. So it has something called Firebase UI. and it's a drop-in authentication solution. And what you can do with this is just like pick up some code from a website and then put it into your app. That's it. You don't need to write any logic or anything. It does that for you out of the box. So let's write our app. And since we're Android developers, the first question that comes to our mind is, where's the API? But what I'd like to show you is this. You don't need an API anymore because we've got you covered. So the real-time database, this is one of the best part that I love about Firebase. I'm sure I'll make you fall in love with this too. It's a cloud-hosted NoSQL database. It has synchronization and conflict resolution. So what that means is, let's say two people are trying to modify some data, and they do it simultaneously from different devices or from different locations. So you don't need to worry about what happens if two people modify the data concurrently. It does that for you out of the box. It's a NoSQL database. I'm telling you that again. So there are no capabilities that you have with your MySQL or your SQL-based databases. But still, it manages to solve that automatically for you. You can access data directly from your app. So again, we don't need any APIs that you want to bug your developers for. So if you're in a hackathon or if you want to make a quick prototype of anything and want to show it to your manager, well, you don't need to knock the doors of anybody else. You can do it yourself. The best part that the Android developers love, it provides everything in JSON format. So you make normal queries, you get JSON objects, and it automatically parses them for you into your plain old Java objects. And you can say bye-bye to pull to refresh. Now, why I say that is because it provides synchronization itself. So let's say we have two apps, and one of them writes some data. In the other app, if you're listening for the changes on that data, you would get them automatically. You don't need to have any pull to refresh functionality. The data comes up automatically, and you get events fired that you can implement the methods for. So, yeah, sorry about that. So let's look at some code. I'm not sure if it's very visible, but I'll still try to explain what it does. It's a very basic thing that you need to do with Firebase. So you get the Firebase database, and you can get a singleton instance using this method called getInstance. And once you have the instance, you can start doing anything on the database, like create a new object called message and set its value to hello world. That's it. You don't need to do anything else. No save, no waiting for OK response from the server or anything. It will manage it for you. The best part, if for some reason there is an error or the user loses connectivity, it will cache it for you offline. And as soon as the connectivity comes back, it will just post it back. So you're still covered, and you don't need to do a lot of handling of the errors that you might have to do otherwise if you're having screwed up REST APIs. Then reading from the database is also quite simple. You get two methods from the value event listener. One is on data changed, and one is on canceled. So on canceled, first, as the name suggests, is due to some error that might have happened, and you'll get the error object there. And on data changed is when you save some data, when somebody modifies some data from their own phone, from some other device, or from anywhere else on the network, you get the changes here. So all you need to do is just listen for them, and as soon as you get the changes, just update your views. So now, I wanted to demonstrate an Uber-like app, which is what I call Iberritos, using this example so you know what this thing is actually capable of. So the real thing in Uber app is how the drivers and the riders communicate with each other, and how you can, as a rider, request a ride, and then drivers that are nearby can just pick you up. So this is a typical scenario. This is our user. Those are some drivers. And this is our database. Now, how do they communicate? The drivers update their location with some metadata into the real-time database using an Android app. Now, if you notice, I've mentioned the metadata separately, about which I will talk in a bit. And it's quite important to know why they do it, why we do it separately. And then your users can query for the drivers nearby. Simple enough. Everybody writing to one database, everybody reading from one database. So you think the problem is solved? Well, no. There is another problem. The problem is the query problem. Now imagine that how do you search for the drivers that are nearby? So if you have like 200,000 drivers and 200,000 users, if a user wants to request a ride, how do you make sure that you only search for drivers that are nearby, and you don't just pull all the 200,000 drivers onto your phone and then start doing some filtering or searching based on that? And then you also want to do that on a NoSQL database. So yeah, it's kind of tricky. The answer to that is Geo Fire for Android or Java. It's a library that Firebase team has created for us, and it allows you to do real-time location queries with Firebase. And because the Firebase team did that themselves, they've made sure that it's extremely optimized, and it does things for you without causing any harm on the device to your app. So it allows queries with geographical areas, and then it has capabilities for selective loading. So what selective loading is, if you want to query for the data only in the radius of, let's say, 5 kilometers, because that makes sense. So it has support for that. And then it stores data in its own format. So now if you remember when I said that we are storing the location and the metadata separately, this is the thing. Because it wants to optimize the operations for your geographical queries, it will store the data in its own format, and it applies an index to it. So how does querying with Geo Fire looks like? It's super simple. You can do it in just one line of code. So here what you have is Geo Query. You get your Geo Fire instance, and then you just do a query allocation with a new geolocation, and at the end, you can pass what's the radius of the area that you want to query for. Getting results from Geo Fire, you might think it's tricky. It's even simpler. You get everything here. So it fires 5 types of events. Because it fires events because that's how your Firebase DB works on the events model. So if the code is not clear, in the next slide, you will see the names of the methods, but I'll just read them out loud. On key entered, on key exited, on key moved, on Geo Query ready, and then on Geo Query error. So any possible scenarios that you can think with your real-time location queries, there are events for everything. So what does it actually do? The key entered. The location of the key now matches the query criteria. So you get this method fired, and now you know that some keys have entered in that area. So in our case, we want to update our maps and show a driver's car on the map that this person entered the search area that we were looking for, and then you can tell like this driver is X minutes away or whatever. Then the next is on key exited. So let's say if you're making a search and there was a driver in your search area, but he just moved out after your search. So you don't need to worry about that, because you will get a method called on key exited, and using which you can just remove the driver from the map interface. So you don't show that driver anymore. And which means you don't need to maintain your own cache and then validate it against anything. The next one is on key moved. So with on key moved, whenever you change location in the search area, and it still matches the search area, you will get this event fired. So this can help us animate the drivers while they're moving in real time. So they just keep on updating their location, and while they're still within their search, you can keep animating the drivers on the Google Maps. Then the next one is on query ready. Now, this method is a kind of a tricky method. which you won't find a use case for in a very straightforward manner. But what it does is when you make a query and it runs some computations on the database and gets you the selected results, this will tell you when the query is ready, and you can now fetch, let's say, start removing the animation that you were showing for the search results that were about to appear. And then the last one is on query error. The name is quite self-descriptive. So there was an error while performing this query. Let's say you violated some security rules or something. So this method gets fired. Now, Geo Fire data storage sample, like I said, that we need to separate out the location data and the metadata. Metadata could be anything. Let's say about the drivers, you have the car, you have the name of the driver, or anything else. But the current location is stored in a separate format, and this is how it looks like. So if I show you a sample DB that I created, there's driver locations, which is used by Geo Fire, and then there are the drivers. And we have the same set of keys in both the DBs. So let's say this driver entered the area, and now you want to show his image or name. All you need to know is the key, and then you can query the driver's tree, and then just show anything that you want from there. One of the most important things that people forget and often come up to me after the presentation, so I decided to address the issues before. Don't forget, it's no SQL, so you don't have the luxuries of your SQL database. Relationships are kind of hard to manage. So what people would generally do is they would nest data structures, which you should clearly avoid, because Firebase supports a tree with a depth of up to 32 children. So you can start nesting everything. But the real problem with that is when you try to fetch the topmost node, it will also fetch everything under that. And you don't want to do that if you want to keep your apps responsive. So you might want to flatten your data structures. A really nice guide about this is available on the official documentation page. It's quite interesting to read. It has very nice examples that you can follow very easily. And then you have to create data that scales because initially you might want to, you might get carried away with oh, it's JSON, let's just dump everything there and then we'll see what happens later. But if you do that from day one, you can actually create a big mess for yourself at the later stages. So now that we figured out that how the drivers and the riders will communicate, we now want to allow user to choose a destination, for which we're going to use a really nice thing. It's called Google Places API. And what it offers is a place picker, an autocomplete, and place details. So these are the three features that the Google Places API offers to you out of the box. And you can just integrate this library. It's available as a part of the Google Play services. Just hook in your library into the Gradle file, and then you get everything. And then this thing is actually location aware. So if you have the location services turned on, it will automatically try to figure out results nearby and do things with that. Another cool thing about this is it allows you to do a global search. So in your app, without doing anything else, just integrating this, you can allow people to search for nearby shops, bars, ATMs, petrol pumps, gas stations, and whatever. And then it has auto-completion features. So just what you see on Google Maps, you can get the same thing with this into your app with just a few lines of code. So, oops. Yeah. This is an example of how you can integrate a simple fragment into your app. So you just need to get the fragment using the library. It provides a singleton instance again. And then as soon as a place is selected in that fragment, I will just show you a demo how it works. You get a method fired, and it's called onPlaceSelected. Do anything with the place that you like. And here's some info that you get with the place object. And if there was an error, you get the status here, and then you can tell the user what's screwed up. I would also like to play this video. Okay. Ooh. So this is a demo for how this fragment would look like. You click on search, you try searching for something. It gives you autocomplete suggestions. And the video goes away too fast, but in the end what it says is it'll show you the place and the details about that place. But this is what the autocomplete actually looks like, and you don't need to do anything for this. There's just a simple view that it has, and just you can use it out of the box. Okay. Next, now that you've chosen your destination, and we, using your GPS coordinates, know your current location. So we have the source, we have the destination. Now you want to find the best route possible to take so that you pay the least amount of fare, you reach in the least amount of time. And for that, we're again going to use something called Map Web Services and the directions API that it provides. Now the problem with this is it's a web API. For some reason, Google still hasn't released an Android or an iOS SDK for this. So you will have to make a request, an HTTP request. The request is fairly simple. You need to provide the origin, the destination, and the mode, which of course in our case would be driving, but you can also switch it to public transport or anything, and then you'll get results based on that. And in the end, it needs an API key that you can simply generate by logging into the console. And then, if you notice the cool thing here, the origin and the destination, you can pass them as human-readable addresses. So even if you don't have the exact address, you can just allow the user to enter some query, and then Google will figure it out automatically for you. And then what you get is a JSON response. Now, the JSON response is quite big. It is impossible to fit it in, let's say, a length of 4 slides also. But it has a lot of data that you can use to do interesting stuff with. What I actually pulled out from there is the legs. Now, what do I do with the legs? I can use these legs to calculate the amount of time that I will take from my source to the destination, and then tell the user that this is your estimated time of arrival. And how do I do that? Is I iterate through all the legs and add up the duration values to get the estimated time. So if you see the legs, every leg has a duration, and then it has a value. You can just add that and iterate through all of them, and then just tell the user that this is your estimated time of arrival. Now, this data that you see here is actually the data that you will also see on the Google Maps. So you get the actual real-time information that Google Maps also get, which is quite interesting. Next thing is, once you've, let's say, got the destination, you've got the time, now you want to display the route, which is also quite simple. So in the same object that I just showed you a while ago, you have something called an overview polyline. It's an encoded polyline object, which you can decode to get like lat-long coordinates, and then just pass it into your Google Maps API's class. There's something called that I'll show you, and you will get a really nice polyline on the map. So you can decode the polylines to get the lat-long objects, and then just plot it on the graph. And in the end, this is how it looks like. This is what the encoded polyline example looks like, just in case you try it out and you don't figure it out. So it's called overview polyline, and it says some gibberish because it's encoded. And the response was actually too big to fit on a slide. I actually trimmed it a lot. But this is what a polyline looks like. Hosting and storage. This is one of the really nice things also that you get for free out of the box. You have an access to easy file storage, so you can store anything there. Like you can serve static assets from there, and it handles poor connectivity, so you don't really need to worry about any CDNs initially. It is backed and accessible by Google Cloud Storage, so you can rely on the uptime always. And it has support for images and videos too, so you can actually allow the users to create content for you. And everything is SSL encrypted by default, so security, if it matters to you. I see a lot of security people here. Yeah, SSL. So these are some of the assets that, as a use case, you could store in the hosting and storage that they provide. Now, what's interesting is that they actually represent the directions, like 8 directions that a car might be pointing in. So if you want to really emulate how Uber does it, all you need to do is just figure out what direction is the driver currently pointing in. You can very easily do that from your phone sensors using the gyroscope, and then just update that with the location metadata. And while they're moving, and if the direction changes, like north, they now face northeast, just change the image. And you can also create multiple sizes. So when you start zooming in or out of the map, then you can also change the size of the image so it looks more realistic, just like the way Uber does it. Also create your own stories in your Uber app, because everybody else is doing it, and we have free access to hosting and storage. Coming on to remote configurations, how many people here have an idea about A/B testing? Great. For the rest of you, one does not simply convert all the visitors. So you need to try and test out things. What works for them? What does not work for them? What color allows a user to buy more happily? If you change the color on the button from red to green, you might see a huge rise in the conversion. So these are the things that you really want in an app if you want to convert more and more visitors. And remote configurations in Firebase allow you to do that. So it's nothing but an A/B testing tool. It allows you to make staged rolled out of your features, and it has direct integration with analytics. So what A/B testing is, I'll show you in a bit. Staged rolled out of features. Let's say you create a new feature. So let's say now with Iberritos, you also want to do Uber tacos. So in your app, you want to now sell tacos or something like that. But you don't know how this feature will perform. So you can roll it out to, let's say, 50% of the users and see what the impact is, how your app is performing with the tacos and the burritos, or without the tacos and the burritos, or vice versa. And remote configurations allow you to do it, and it's pretty simple to do. You just go into your Firebase console, and let's say, for an example, I create an Italian discount. So what I want to do is I want to convert Italian speakers since I'm in Italy, and if I figure out that a user is an Italian user, and you can do that, let's say, using the country in which the device is right now, you show buy or a try thing. And then to other users, you show a buy or a try thing, depending on what your condition is. And all this you can get using a single call. So you just make a call like config.getBoolean, and then you pass the string called Italian_discount. If it gives you true, you show one part of the UI. If it gives you false, you show another part of the UI. And then you can measure like what you want to do with them. And the power of A/B testing, I'm pretty sure all of you would have worked with your designers, and at times they like tend to get a bit more pushy about like, I'm the designer, I know what works and stuff like that. But no, once you get A/B testing integrated into your app, this is what you can do to your designers. And then they will tell you the data says otherwise. Talking about app indexing, who knows here about app indexing? Okay, only one person, a few of them. Who knows about indexing? Cool, that's the same thing but in the apps. So app indexing actually allows you to point your users from the browsers to your apps directly. So if somebody makes a search for some content that is automatically available in your app, Google will index that content on the phone, and then it will surface links to your app's content if it's installed. And if not, it will put like an install button right in the browser next to the search result, and then users can click that and come into your apps. Now, again, install button. The install button actually for your app appears next to the homepage search results. So it gives users an easy path to installing your app and then view the content from there directly. It has support for autocompletions. So I will show you a really nice example in a bit, where if you're typing something and there's some related content on the phone already, Google will actually give those results right there, and then you can hook the user into your app from there. Assistant. So App indexing also powers the stuff of the publicly available content of your app into Google Assistant, which is like on Pixel and on Allo, which is the new messenger that they try to copy and launch. And then something called ad targeting. So if you're using AdMob to monetize your app, you can index, and AdMob will work together to improve the quality of the targeted ads that you have for the public content in your app. And it can really help drive increased advertising revenue for you. Next thing is like notifications. So it's built on top of cloud messaging, which we used to call Google Cloud Messaging. Now we refer to it as Firebase Cloud Messaging. And then what you can do is you can send notifications to through three types of channels, like custom audience targeting, topic-wise broadcast, and single device push. So what is custom audience targeting? So let's say we're doing some sort of promotion in Turin. And through your analytics, you can actually create a user base, like if a user is in Italy, if the user is close to cities in Turin, just send the notifications to them. So you don't send it out to a whole bunch of people because you don't want to bother all your users. You just want to target those users. You can create these custom audiences using your console, which is like looks something like this. It's like an analytics dashboard. You can also do a topic-wise broadcast, which I'm not sure if you're aware of publishers and subscribers. So people can subscribe to topics, like the apps can subscribe to topics, and then you can send notification to those topics only. And then you can also do a single device push. So in our case, when we're making an app like Uber, when the rider accepts your ride, you might want to notify the user. And when the ride is completed, you want to notify the user again. This is what you can do with a single device push. So you just push to one ID. Now, here's something that I want to show you. I told you it's app indexing in action. So this is my phone, and I search for Brexit. And there is an app that I have installed on my phone. It's called InShorts. It's a news app. It gives you summaries of news. So I see 3 results. Now, probably this app has some content related to Brexit. So what I now do is I actually click on the third news, which says, "We already miss you. EU president tells UK over Brexit." As soon as I click on this, I actually enter the app, and I'm straight away presented with this screen. Now, this is what app indexing can do for you. Even though the user was trying to find something on Google, but you drove him back from Google into your app. And I'm not sure if you noticed this, but the irony of this slide is that while I'm telling you how to retain users into your app, UK is actually exiting EU. So dynamic links and invites. If you want to have more users acquired, now you also need something to spread the word. And Firebase, again, comes to the rescue. So it actually automatically creates deep links for your content. And then that provides low friction for users to install your app and start using it. And then installation flow survival. So what happens is, let's say I shared a link with you to buy some sneakers for 20 euros, which were otherwise for 60 euros on an app. And you immediately see my message, and then you're like, I want to get those sneakers. As soon as you click on that link, most of the screwed up apps would actually make you install them and then just show you any gibberish like inventory that you may or may not be interested in, but they actually lose the customer, and you're no more interested in using that app. So what you can do with these dynamic links is actually you can survive the flow of the installation. So when you clicked on that ad that your friend shared with you to buy those sneakers for $20 or euros, it will store the information. Now, because everything is tied up with Google, okay. Now, since everything is tied up with Google, the Play services make sure that all the data is stored throughout. And then once the app is installed, you will automatically be taken onto that screen. Now, obviously, as a developer, you will get a broadcast that you need to listen to using the intent and then pass the data to your views and then show that screen. But imagine how good it would be to convert a user directly from another app who did not have your app like 5 minutes ago. So he just comes to your app, looks at those 20 euro sneakers, buys them. Well, you've got the money, and you also converted a user. And now this user might be like willing to come back to your app because he knows he bought those sneakers from your app. And he can in turn also spread the word for you. So now you can see like how good this flow is, which obviously leads to higher conversion. And this is a graphic like it can automatically generate shareable content for you and things like that in that manner. So this is like how deep linking looks in action. So with deep linking, the user straight away goes to the screen that he actually wanted to visit. But without deep linking, it first gets to your app and then has to search to the content and then leads there. So you're actually reducing the time that it takes for the user by half, exactly half. About the quality, so when you're writing an app, you want to make sure that things don't break in production. Of course, they will. But there are maximum things that you should try to eliminate before you push the code to production. So there's a test lab, and you can test on the most popular devices before you ship. So these devices are in the cloud, and you can get reports and screenshots while you run the tests. And you can run robo or custom tests. Robo is a kind of thing that Firebase provides. So if you've never written tests before, UI tests, any sort of tests, you can use that thing. It's pretty easy to write tests in that. They're like behavioral tests. And you can just run them on the fly. It can also give you activity flow hierarchy. So if you want to know like which places your app cramps up a lot, which views, which animations stutter, you can get that info from this. And then you can also get a test video recorded for the whole session while the app was running and the tests were being performed. This video is not a very like super nice HD quality video. What they actually do is they stitch all the screenshots, and then with the help of time, they create MP4 vids for you. And it's all in the cloud, so you don't need any devices by yourself. It does it for you automatically. It also has support for crash reporting, which I mentioned. And you can, the very nice thing about this is the ANR actually flows through the Google Play services now, and it is logged here. So if you get the native crashes and those kind of things in your app, you will still be able to see them here, and you just don't need to go to your Play developer console over and over again. And again, it has direct integration with analytics because it's always at the center of the screen.